Let's see what the post has for me today. Okay, so we have some manner of electronic kit. There's a chip there, a rotary encoder, and here we've got the PCB and a Perspex box. Some instructions here. Oh yeah. So this is a function generator based on the XR2206 chip. So it's a dedicated function generator chip, and it's just got a few support components. So it should be quite easy to build. So I can get on and do that. So unpacking the parts of the kit, let's see what we've got here. So we've got the printed circuit board, which has got quite a good silk screen on it to show where all the components go, through hole design, and it's quite nice. All the blank areas are filled with ground plane, so it's a nice design for audio. And then we've got the case, which is one of these Perspex designs. So you got various bits of Perspex. I've peeled the backing paper off it already. So you just basically plug all the pieces in together, and it's held together by a few nuts and bolts. We've got the three control knobs. We've got three potentiometers. We've got power socket, some capacitors, a couple of jumpers, little jumper tops there. I guess that's where the output comes out, not sure yet. And then we've got the chip itself, the XR2206 with a socket. And I'll definitely use the socket because I've heard some of these chips are counterfeit and they don't all work 100% in these cheaper kits. So we'll see. Okay, so we'll start assembling. So we'll start with the smaller components, the resistors and the capacitors, and then I think we'll probably put the chip socket in and work our way through the taller components like the electrolytic capacitors. So the soldering iron's warmed up now. I have the instructions for the kit, so I'm going to be using this table here that tells me what the components are to place them in the board. And I've got a cup of tea, very important. So let's start putting the resistors in. So this one has got two orange bands, so this is the 330 ohm resistor R4. So R4, which goes over here. And this one, so that's got brown black starting. So this is the 1K R1. And then the remaining three are the same value. So right, so we've got R5. Oh yeah, oh yeah, R3, R5, R6, and those are all 5.1K, so let's put those ones in. So there's not many support components on this board, in fact, because the chip, the XR2206, has got nearly all the logic that it needs. We've just got a few crucial capacitors to go in there. It's quite a nice chip, the XR2206, and some years ago it used to be really expensive, but now you can get these kits for really very little money. There we are. The lead's trimmed down now. I could do with a bit more. Right, so that's the resistors in place. Now we can go for the IC socket. So what I like to do with the IC sockets is just tack down a corner double check I've got it the right way round. So there's a little cutout there at the top to show you where the top of the chip is. It seems in a good position, so I'll just tack the other corner as well. And that's nice and flat. I can do all the rest of the pins. I much prefer these through-hole kits to the surface mount ones. They're much easier to handle. You don't need to fiddle about with the magnifying glass and with tweezers, and it's just much faster to get the thing assembled. So we'll put put this set of jumpers in, I think, here, and then the capacitors next to them. I have to be a bit careful to get the values in the right place. So C8 there, the value is 101, which is that one there. C8 in. Next one is C7, which is the 222. Next is C6, which is 105. That one. And then C5 is, oh no, that's C6. No, that's not right. So C5 is the 105, and then C6 is 473. Okay, let's just get those in place. All the little caps in place. Push that jumper in. Okay. And I can put some electrolytic capacitors in as well. What's this C2 here? Oh, I missed one, haven't I? C2 is the 104. Just needs to go in over here. Okay. And C1 is 100 microfarads. It's really rather physically small for 100 microfarads. So this one being electrolytic, you have to get in the right polarity. So the white strip down the side is negative, and it's marked on the silk screen here. So you got a white section, a hatched section. So that goes in there. And there's two more electrolytic caps, C4 and C3, which are both the same value, 10 microfarads. So got two of those. Once again, got to get the alignment right. Okay, so that's most of the components done now. So there's another jumper goes up here. And then that's just about it. So I mean, all we need to do now is fit the various sockets and potentiometers on. So the potentiometers, these ones are marked underneath. So you see this one says B503. So if I remember correctly, B means it's a linear pot and A means it's logarithmic. So the A pots are used for things like volume controls, but these are for setting frequency, I think. So it's a linear one. So the B503, there are two of those in this, which are R2 and R7. B503, yes. So these go in R2, R7. Oh, R7 is that one, which leaves R8 as a 104, B104, yes, there we go. So these have got some extra tags on them which you solder to give it physical strength. So that's just holding the case of the pot in good physical contact with the PCB, and then the actual component tags are these ones here, the three together. So let's get some solder on there. These have got quite a lot of thermal mass, so takes a lot of energy from the soldering iron to get that all melted. Okay, so that's the physical tag, and they look like they're nice and flat on the board, so I'll go ahead and solder all the other ones now. Right, and so got a couple of other things here. We've got the power jack over here. Let's put the power jack in. This one's got quite a bit of thermal mass as well. It's quite difficult to make the solder melt on that one. Okay, so there's the power jack in place. Oh, it's lifted up a little bit. I wonder if I can improve that. Let's just melt the solder, give it a little push. No, that'll have to do, I think. Slightly lifted up, but it'll be alright. And then we have this is the output of the unit. So you can see on there it says SNTR, sine triangle I suppose, and square wave. So we want that way round where you can get the wires into it. Okay, that looks quite sound. So, what needs to be done now? I think the jumper goes triangularly across there. Right, so this is obviously the adjustment, selecting these different capacitors. And now we want to get the chip in, so the chip it's got a cutout, show you where the top is, so we'll get that aligned. Need to squeeze the edge of the chip a bit to get the pins to go in the holes. There we go, that's good and solid in the socket. And there we go, we've more or less finished now. The other thing to do, of course, is to put it in the case. this is the top of the case. It's got some laser cut legend on it, so you can see what's happening. There's still a bit of paper on there. Okay, so we'll try and get the bottom in place. Well, that one doesn't quite fit. Oh yeah, just need a bit of brute force to get that in. Okay, so that's all flat and in place now. Drink of tea, of course. And put these screws in. Somehow. Oh, it's not quite sitting flat. I need to kind of squeeze that into its hole a bit better, maybe. I think these potentiometers, it's not quite settling around the potentiometers. Is that better? Yeah. Right. These screws don't really seem long enough. Well, there we go, it's a bit sort of self-tapping at the end there. Maybe that's the intention. There we go. So they go into these little holes that have a smaller hole cut into them, so you're actually biting into the plastic with the screw, but that assembles fairly tightly, so that's good. That's all assembled, and now what we need to do is power it up, and oh, we could put the knobs on, of course. Let's turn all these down to the left. Okay, so we can break out the scope now, power this up, have a look at the waveforms that are coming out of here using the scope. Okay, so I've got 9 volts here. The manual says 9 to 12 volts is what this thing needs to run. And right, so if we jumper this for 100 Hertz to 3 kilohertz, and I've got my little amplifier over on this side connected into the sine triangle wave, and that's the ground pin, so I'll plug it in. And there we go, so we've got an audible tone. So this is amp, fine, coarse, so these are the frequency controls. This amp or volume control actually works backwards, so as you turn it anti-clockwise it's becoming louder, which is a bit quirky. So we've got frequency control there, and this is fine control. Let's change to the next jumper. Oh yeah, it's a nice high frequency. and that goes right up into the inaudible. Well, it says 65 kilohertz. Is that 65 or is it 85? I'm not sure, but that's well above the range of human hearing anyway. Right, so that's basically working. So let's connect it to the scope and we can actually have a look at the quality of the waveform. So on the screen now we've got a bit of a sine wave. I mean, there's a bit of jumping. It looks like the phase is changing a bit because this is set to, I think the trigger is set correctly. Could just let it reset itself. You can see it's quite a nice sine shape. And that's reading 3.6 kilohertz. We're on the 3K range here. If I change the frequency on this range, it's only going up to 11 kilohertz. It's meant to be 3 to 65. Oh, I can do more on the fine as well. Right, so it goes right up to 85 kilohertz. So that's well outside the range of human hearing. But the sine wave's not bad. I mean, you've got a few little kind of glitches here, but that's a relatively high frequency. So we get 18 kilohertz. Let's switch to the triangle wave. And you see that's a good shaped triangle wave, really very precise. And you see we can change the amplitude here. It's above there, above about a quarter, it does start to get quite distorted there. You see it's actually clipping the top, so it becomes more, well, it goes slightly sinusoidal, doesn't it, but then eventually ends up in a square wave. So you don't want to have this thing turned up too high. What else? There's also the square wave output, isn't there? So let's go on the square wave output. There we go. It's not too bad, is it? There's a slight slope down, isn't there? So it's slightly trapezoidal rather than a square wave. I wonder what happens if we go right up the frequency again. So that's 84 kilohertz, and it's not bad. I mean, it still has this slightly trapezoidal characteristic. There's a bit of extra noise at these higher frequencies, but altogether it's really not that bad. So that's good. I mean, that's an interesting and fun little kit. It cost about £5. I bought it from Aliexpress. I'll put the link down below if you want to go and buy the same. But I think, you know, for £5 that presents quite good value for money. You know, so you've got the triangle, the sine and the square, and that's actually quite a useful little function generator. So recommended.